So in this video, we're going to show an example of applying the chain rule when the quotient rule is also involved and when we have to do a subsequent simplification. So it says find the derivative of f for f of x equals x over the cube root of x squared plus 1. So I can see right away that I have a ratio of functions. So I know that I'm going to need to use the quotient rule. So I have f of x equals x over the cube root of x squared plus 1. So I've got a quotient, I'll need the quotient rule, and then I also have x squared plus 1 inside of the cube root function. So I have a function in the denominator, I have a function composition going on, one function inside of the other. I have a cube root function, and inside of the cube root function I have the function x squared plus 1. So I'm going to want to rewrite this function so that the radical form in the denominator is written using a rational exponent instead. So I'll rewrite this as x squared plus 1 to the 1/3 power, so converting the radical form into the rational exponent form. And now I'm going to take the derivative. And because it's a quotient, I'm recognizing I need to use the quotient rule. And the quotient rule says take the derivative of the numerator and multiply that times the denominator. So the derivative of x is 1. And we do 1 times the denominator, x squared plus 1 to the 1/3 power. And then the quotient rule says subtract from that. It says now take the derivative of take the numerator, and multiply it by the derivative of the denominator. So the numerator is x, and we need to multiply by the derivative of the denominator. And so here's my inside function, and and the outside function is the cube root function. So we're going to take the derivative of the outer function first. So that 1/3, I can take the derivative of stuff to the 1/3 by using the general power rule. So I'm going to bring the 1/3 down into the coefficient position times. We need to reduce the exponent by 1 using the general power rule. So I do 1/3 minus 1 is -2/3. And then the chain rule says take that derivative of the outer function at the inner function. So the inner function is x squared plus 1. And then the chain rule says you need to multiply by the derivative of the inner function. So by the general power rule, the derivative of x squared is 2x. And the derivative of the constant 1 is 0, so I get 2x plus 0 is just 2x. And then all over by the quotient rule, I'm having to use the quotient rule. The quotient rule says square the denominator. So I have x squared plus 1 to the 1/3, but then I have to square that. And then I'm going to need to kind of clean things up and simplify a little bit. Yeah, sorry, I was just looking to make sure I didn't have a mistake. So I'm going to clean things up a little bit here. So I've got my x squared plus 1. Those pregnant pauses are bad on video. That's okay to do it in the class. I've got the 1/3 sitting here, minus, and then here I have an x times x is x squared, and I have a 2 times 1/3 is 2/3 of an x times x is x squared. And then we have the x squared plus 1 to the -2/3. And this is all over. When we raise one exponent to another, we multiply the exponents. So this is all over an x squared plus 1 to the 2/3 power. So now we're going to take a look at what's going on here, and what I want to notice is that the base x squared plus 1 is showing up in the denominator, but it also shows up, there's two terms in the numerator. It shows up here, x squared plus 1 and x squared plus 1. So we need to do some simplifying in the numerator, and what we want to recognize is there's going to be more than one way to correctly simplify things, but one method for simplifying it is to look at the common base and then look at the exponents that you have. Here I have a 1/3 and a -2/3. So one method is going to be to take the smaller of the two bases and factor out the base, sorry, the smaller of the two exponents and factor out the base raised to that exponent. So I'm going to step over here and I'm going to continue simplifying my derivative. And I'm going to look at the 1/3 and the negative 2/3 and recognize that negative 2/3 is the smaller number. So I'm going to go ahead and factor out x squared plus 1 to the negative 2/3. And that's going to leave behind some stuff in the numerator. So I need to figure out what goes here. I know it's going to be an x squared plus 1, and then you have to figure out what power goes here. And what we want to recognize is when we multiply a base times a base, we add the exponent. So I need to say, what exponent do I add to negative 2/3 to get the 1/3 that I started with? And in this case, it's actually just going to be a 1. So if I do 1 plus negative 2/3, I get 3/3 plus negative 2/3 is 1/3, which is the exponent that's sitting there. So I leave behind, when I factor out an x squared plus 1 to the negative 2/3 from this term, I'm left with x squared plus 1, and this is going to be minus. So minus, I have 2/3 of x squared. And because I've factored out an x squared plus 1 to the negative 2/3, that's all that's going to be left for my second term. So I leave that over there. And then this is all over the x squared plus 1 to the 2/3. I get x squared plus 1 to the 2/3 power. And now what I want to recognize is that I've got that negative exponent sitting up here. If I bring it down into the denominator position, x squared plus 1, instead of a negative 2/3, I'm going to have a positive 2/3, and it's going to be multiplied by the x squared plus 1 to the 2/3 that's already sitting down there. And in the numerator, I have an x squared plus 1 left minus a 2/3 of an x squared. And then I can simplify that numerator a little bit. I have x squared minus 2/3 x squared is going to be just a 1/3 x squared plus 1. And then it's going to be all over. I have a base being multiplied by the same base. They're both raised to an exponent, so we simplify by adding the exponents. So I get an x squared plus 1, and 2/3 plus 2/3 is going to be the 4/3 power. And then I can clean things up here a little bit. I have this fractional exponent on the x squared, so if I just multiply by 3 over 3, which is equal to 1, I can clean things up a little bit and get rid of that fractional exponent. So 3 times 1/3 is 1. 3 times 1/3 x squared is 1 x squared plus 3 times 1 is 3. So distribute the 3 into the numerator. And then I have a 3 times an x squared plus 1 to the 4/3 sitting in the denominator. And that's about as simplified and clean as we can make this.